Negative 3 plus negative 8, it is negative 11. So to go back to what you were saying, though, because this happens a lot, especially in this part, well, in this whole unit, really. Because a lot of students are going to say, look, you got a negative here and a negative there, and two negatives make a positive.
Yeah.
That's for a different operation. That's multiplication. But when we do addition like this, if you start with negative 3, the negative 8 actually is just going to make it more negative, which is why we end up with a negative answer. And then you do 3 plus 8, which is 11. So the 8 is in parentheses, because if I wrote it without parentheses, this is what it would look like. Now, that may make sense to you, especially seeing the original problem, but the problem for math nerds like me, not that it actually bothers me so much, but math nerds are like, what the crap is that? Do you want me to subtract? Do you want me to add? Do you want me to add a negative? Do you want me to subtract a positive? What is going on here?
Right.
And so math people feel a lot better if you're like, and that, I mean, you'll see them feel the relief, like, oh, okay, now I can do this problem. That's a great point. So this, parentheses don't always mean multiplication. When we start dealing with negatives like we are now, then sometimes it's just a way to separate a negative from a plus sign so we don't get it mixed up as a plus, a minus, or plus minus, which sounds really weird.
Yeah.
Just as a quick review of what we talked about last time, if you're adding and the signs are the same, and this is the way that we do it. First, we want to figure out the sign of the answer, and then we can operate. So if the signs are the same, whether they were opposite or whether they were positive or negative, these ones are negative. When the signs are the same, like negative, then the answer is automatically negative. Then if we're adding the same signs, then we add the two numbers. 3 plus 8 is 11. If they were opposites, you have to look at both numbers, see which one's bigger. Whichever one's bigger, that will be the sign of the answer. And then you take the big one and subtract the small one, because what happens is they zero out. So if I was to look at this second example right here, now the signs are opposite, right?
Yeah.
But the thing is, for every positive and negative, they're going to zero out each other, right? It's like you have $1, but you owe $1 combined, you have a net worth of 0.
Yeah.
Is what it is. But this time, there's more negatives here than positives. So in the end, once I actually do combine these, which I will, I'm expecting there to be more negatives, because I'm expecting the answer to be negative because there are more negatives between the two. From here then, what you do is you take the big number, which in this case is 5, and you subtract the small number, which in this case is 4. So 5 minus 4 is 1. Now 1 is not your answer, because remember the negative sign, which we now attach to the answer, making it negative 1. So these 4 positives zero out 4 of the negatives, and what we're left with is just one individual negative. Last time it was understanding integers 3.1 and then adding integers 3.2. Integers just a really fancy way to say positives and negatives. So this is the first unit where we're actually seeing negatives, just like we saw on that starter problem. So it would be nice if we could change subtraction problems into addition, because then we only have to memorize those rules for combining negatives. And then, yeah, we should be able to subtract any set of integers, whether they're positives or negatives. Maybe there's lots of positives and some negatives, or vice versa, and then we can combine them all together if there's lots of them. This slide is just demonstrating what you may see on the assignment. So last time, this is the way we did it with the tiles. Last time we were using positive, and we call these tiles positive and negative tiles. A positive tile and a negative tile will zero each other out. They just make each other go away because they're zeros.
Yeah.
And zeros are, at least in math, are kind of like people that we consider zeros. We get to ignore them, which is, I mean, that's messed up, but
It's okay.
it's a nice math. Weight related. So it says, now they look like this. Okay, so now instead of these tiles, they're just going to be in circles, and the colors are different. Which model shows 2 minus 3 equals negative 1? The only one that I can see that resembles a final value of negative 1 looks like it's this one right here. Oh. Okay, so let's look at these other ones. In fact, let's look at this one right here, okay? So 2 minus 3, So it'd be like you start with 2, and then you're gonna take 3 away. So, I mean, where does that -1 come from? Well, what happens is you have 3, these are 3 positives, and the minus sign says that you're gonna take them away, so that's why it's got the arrow coming out right there.
Yeah.
Now this one, of course, you're only taking out 5 positives, but the problem is that leaves us with these 3 negatives. This one right here, it just starts with 5 negatives and it stays that way, but we know it can't equal -5, so that doesn't work. The -3 doesn't work, so I guess we can just kind of cross those out. And then this last one, this last one, it's showing a 0 pair here and here, which would be fine, those 0 out, right? But the problem is that it leaves you with just an individual positive, not a negative, whereas the answer here is showing as a -1. So this is the only one that seems to make sense. Unfortunately, the number lines are still going to be on the assignment, so there we go. That's so we've seen this already. This exact same slide we've seen already. In fact, we saw it last time. And the way this sets up on the assignment, the bottom one, this bottom dot or I don't know point, it's with the starting value. So it's the first number in the I guess subtraction today, and then this one tells us how far to go. Now, really, with either subtraction or addition, it's just a matter of direction. Well, yeah, so this is saying, yeah, further to the right makes it bigger, further to the left makes it smaller. The thing we need to understand, though, especially with subtraction, is that, like, if you're subtracting a positive, which we've seen before, that makes you go to the left, because you're taking away actual value. But if you think about this, and this is where it can get confusing, if I start to take away negatives, like if you have debt and I take away your debt, then I have just increased your net value, which is why if you see minus a negative, then we go to the right. This way that I'm explaining it is almost strictly for this number line stuff. The truth is that we have other methods to use. Students like to look at it like this as well, where they're like, hey, look, I got minus a negative, and what we saw last time is 2 negatives, including the minus sign as one of the negatives. 2 negatives make a positive. So if you see minus a negative, you can just change it to plus. Okay, so we got to show -7 minus -9 on this number line. So the -7, the first number in our subtraction problem, is where we will start. So the bottom dot or point, we're going to move this over to -7. So that's going to be right there. Okay, so we have our starting value, and when you do this on the assignment, you move this bottom one over to the starting value of -7. It will move the top one usually with it. Now, the next up, it's saying we're going to minus negative. So we'll try to type this in. Minus a negative. Oh. Let's see if this helps. Minus a negative is the same as taking away a negative. Yeah, sorry, this is so minus a negative is the same thing as taking away a negative, but like I was saying on the last slide, is a lot of students like to say, well, 2 negatives make a positive. Let's see, there it is again, positive. Okay, so minus a negative. So think about this. The minus direction usually, the minus would usually say go to the left. But having a negative right there tells us to do the opposite of the left, which is to the right. Now, that's kind of what that first statement is saying. Now, if we go back to the original problem, -7 minus -9 like this, what some students like to do is they just like to make that minus negative stuff a big plus sign like this, which then tells you that you're going to start at -7, but you're going to go to the right 9 from -7 right there. The truth is, both are going to do the same thing, so it doesn't matter which way you look at it. But again, most students do like to see it like this. So let's go to the right 9 spots. So from -7, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where we end on this one. meaning I would take this dot right here and move it over to 2. And, well, that's where we should end that. This is kind of what we're seeing on that second part of that last one. If you see minus a negative, again, we would say two negatives make a positive. And so if you see that like this, you can just simply write it like this. This abstract, so the letters would usually represent numbers. So I mean, it could be 5 minus negative 1. You just really change it to 5 plus 1, which would be 6. Now just, I'm going to try this again. You don't have to like it. But minus means you're taking away negatives, and if you're taking away negatives, like taking away debt, which increases overall value. So the good news about these types of problems is really what we are doing is changing these into addition problems, which they are going to ask you to do on the assignment on some of the problems. So be aware. They're going to say, make this an addition problem first. Okay, fair enough. So that we would keep the first number as it is, but the minus negative right there becomes a plus sign, and then we just end up adding 12. So this is where we get back into the last lesson where it's like, look, if you can just change any subtraction problem to addition like we've just done right there, then you can just look at what we did in 3.2 and just keep those rules. So if I were to look at this based on the rules we saw last time, and you may or may not have used them, but I would look at these two numbers and I would see there's more positives than negatives, and they're opposite signs. Since there's more positives than negatives, I would expect the answer to be a negative. Then you would take the big number, 12, and subtract the small number, 6, in order to figure out the actual sum, which may sound weird because we're subtracting, but 12 minus 6 is 6. So yeah, positive 6, I mean, you know, however you, I'm not going to include the positive, but it's there. I have it there. I was holding it there just so we know that the answer was going to be positive, but you don't necessarily have to write that in. Yeah, on this one, minus the negative right there, we definitely will change that to a plus. So it becomes 74 plus 26. They're both positive now. Yeah. So we're going to take the 74 and the 26, and we will add them together. To get 4 plus 6 is 10, carry the 1. 1 plus 7 is 8, plus 2 is 10. And we end with a positive 100. So, just like the last one, it's minus a negative, so we're just going to change that to a positive. Really now we have two positives being added together, 621 and then 537, which now that we're adding them together, we should be able to solve. So let's see, 1 plus 7 in the ones place value is 8. 2 plus 3 in the tens place value is 5, and then the hundreds place value, 6 plus 5 is 11. So 1,158, that'll do. Okay, so let's go through this one just because we've changed the 621 from a positive, now it's negative, so it's definitely going to change, but this part is not going to change. The minus and negative is still going to end up being a plus. Now here, between these two numbers, I know 621 is bigger than 537, and it is negative. So like I was saying before, the first thing I would want to find out is if my answer is positive or negative. This should leave us with negatives after the 537 positives cancel 537 of the negatives, which means we're going to take 621, the bigger number, and subtract the smaller number, 537, subtract. Okay, so what do we get? Borrow there. 11 minus 7 is 4. And we'll have to borrow from the 6. 11 minus 3 is 8. Now again, the answer is not 84. It's negative 84 from the negative sign that we knew the answer would be from before. Subtraction as addition as well. If we were to subtract, as it turns out, it's the same thing as adding a negative, which again, they're going to ask you to do on the assignment. So, for example, let's put this into practice here. So let's say that they gave us 7 minus 18, whatever. And he said, change this into an addition problem. Well, we're going to keep the 7 and the 18 where they are, but the minus sign becomes a negative for the 18 right there, so we can put that in parentheses, and when we do that, we can make this an addition problem instead. Why would we want to do this? It's because if I change this into addition, just like we did with those last few problems, if the signs are opposites, like these two are, then we can just apply addition of integer rules to this type of problem as well. So -1 minus 15. So let's first change this into an addition problem, and then we'll actually solve it. Now, let's change this first just into an addition problem, just like it will on the assignment. So I look at this as -15 right here. Not really minus 15, so I would look at this as -15, which I can put in parentheses, and then it allows me to change the operation to addition. I'm hesitant to do this, but it does help some students. When you're subtracting, especially if you're subtracting, some students like to do what they call keep, change, change, and that's specifically with the signs and operations. So if I said to keep, I would keep the first number, whatever sign it is. This one just happens to be negative. And then you would change the second one. And again, the reason why we would change it is because we would want this to be an addition problem instead. Now that minus 15 would be like minus positive 15. So then we would have to change the positive 15 into the negative 15, which we've done there. Keep, we've changed and changed. Now again, this changes it into an addition problem, but between the two, they're both negative, adding together, which means that the answer must be also negative. Then we can take the two numbers, since they're both negative, 1 and 15, and all we got to do is add them together. So 1 plus 5 in the ones place value is 6, and then just drop the 1 in the tens place value. Of course, it's not just 16. The answer will be a negative, like we saw before, so negative 16. I guess on this one, so let's change it to addition first, right? And again, I'm going to say keep, change, change. So the 18, which is positive, it started positive, we'll keep it positive. The operation from minus will change to addition, and then the 25, which is positive, I would change to a negative 25, like this. Keep, change, change. Now that's an addition problem, we could say, well, we're adding the two together, they're opposite signs, so there's more negatives than positive, which means the answer will need to be negative as well. Then we take the two numbers, 18 and 25, the big one, specifically 25, and then the small one, 18, and simply subtract them. So we'll make this 15 minus 8, which is 7, 1 minus 1 is 0, but the 7 we'll have to attach the negative onto. Now that's one way to look at it. Another way to look at this is, at least for the sign, you start with like 18 bucks. This would be like spending 25 bucks. So you've spent more money than you have, which also would make the answer a negative. And then from there, it's the same thing. You'd actually do 25 minus 18 to see how negative the answer is, which again would be negative 7. Same answer, just kind of looking at it two different ways, but they will require something like this on the sign where they say, change this minus problem into an add problem. All right, so they're gonna have stuff like this on the assignment, and since we enjoy this, we're gonna enjoy it a lot. So select all the true statements, okay. It says, starting at the top here, subtraction is equivalent to adding the opposite. Really what this is saying is keep, change, change. So yes, you can keep the first number as it is. If you have subtraction, you can make it addition, but then it changes the second number into its opposite, which is the change part. So yes, this one does work. We will say check mark. That would be true. Next, when subtracting a negative number, you move left on a number line. No, subtracting a negative is the same as adding a positive, or just like minus negative means that we're going to change the operation to plus, which means you would go to the right. So this one is false. We will leave it blank. The next one, the difference of a number and its opposites gives you 0. Difference minus subtracting opposites, no. Now, if it said adding opposites, which would be the sum of a number and its opposite, then you would be combining opposites, which would give you a 0 pair. But the difference may not always do that. So this one is not always true, or it's just outright false. The next one, 0 minus a number is the same as a number minus 0. This is like the commutative property of subtraction, which does not exist. You cannot change the order of numbers with subtraction. Now, if you change that into an addition problem with negatives, you could, but the way that's written, it will not work. Next one, a positive number minus a negative number. Minus a negative, always a positive number, yes. And that's specifically because the minus a negative is going to change that to a plus sign, or really a plus a positive, which then will make that overall answer, since you start with positive, you've changed it now to adding a positive, your answer will automatically need to be more positive. So subtracting a minus b is the same as adding a plus negative b. Yeah, we saw this one. It was on one of the other slides. Or if you wanted to look at it, you'd keep the a the way it is, change the operation to addition, change the b from a positive to a negative, keep, change, whatever. When adding a negative number, you move left on a number line. When you add a negative, that is correct. Yep, because you would be adding a negative, which is going to make whatever you have more negative or less in value. So yeah, that one's true. And then the last one, subtracting a positive number from a negative number. Subtracting a positive from a negative always gives you a negative number. A positive, yeah. So if you start with a negative and you subtract value, then you're taking away value, meaning you're going further into negatives. It's like saying you start with debt and then you'd be spending more money, which means you'd have more debt. Yes, that is true. That's 3.3. I can change subtractions into additions, and then we should be able to subtract anything. Feel pretty good about that.